problem is asking us to let the polynomial p of x equal 3x cubed minus 5x squared plus 3x minus 10. We would like to completely solve the polynomial equation p of x equal to 0, given that 2 is one solution. So there are several things going on in this problem. First off, what degree is that polynomial? Third degree. How many solutions can it have? 3. It can have as many as its degrees. It can have as many as its highest power. And in fact, it will have that many unless one of them turns out to have a multiplicity greater than 1. So unless one of them is a double root or a triple root, it will have 3 solutions. Now if you look at that polynomial and notice it will not factor. It has 4 terms, and the only way to factor it for us would be what? Anybody know? If it were going to factor, the only way to factor it would be by grouping, right?
Yes.
But even if we try to group that, if we group the first 2 and we group the second 2, or the first and third, nothing will work. Okay, there's no way to factor that by grouping because the factors don't work out so that they will have a common factor. Because of that, we need an alternate way to solve this equation. So they threw you a bone, and they said, look, you don't know how we got it yet, but we know that 2 is one of these answers. We know that 2 works. We know that when we divide by x minus 2, we get a remainder of 0. We know this. And in the next section, we're going to learn how they found that 2. But for now, we're just going to take their word for it. And since we know that 2 works, we know that when I divide synthetically by 2, what should my remainder be?
0.
Should be 0. So let's take a look at that and see where we get. So I set everything up, I put my synthetic divisor in the box, and I listed my coefficients from highest power to lowest power. And I'm going to multiply 3 times 2, and add those together, 1 times 2, and add those together, and 5 times 2, and sure enough, I get a remainder of 0. Right here, this bottom piece right here, means that my answer is 3x squared plus 1x plus 5 with a remainder of 0. Make sense? That means that if I take this guy and I multiply it by x minus 2 and add the remainder of 0 to it, what does it have to equal back to?
P of x.
It has to equal back to p of x. This is a way of forcibly factoring something that has been previously algebraically unfactorable to you. There is no algebraic method for factoring that polynomial, but once you figure out where the 2 comes from in the next section, you can force factor any solvable polynomial as long as one of its roots is rational. So that's important, you guys. And this is the way sometimes you would actually type in a division answer into WebAssign. Sometimes you would type it in as we did in the previous example, but sometimes you'll type it in this way. And WebAssign will tell you which way to type it in.
When you're typing in, would you have to put plus 0 or do they?
You wouldn't, but you would have to put plus whatever if the remainder weren't 0. Okay, so that's one way you could actually type it back in, and that would equal back to the original p of x. Now that is forcibly factoring it down. What that means is that now we know that x minus 2 times 3x squared plus x plus 5 plus that 0 there that we don't have to actually show because it's your remainder equals 0. And we know one of the answers is positive 2. We were given that one. How do I find the answer to this problem?
7 equals 0.
Set it equal to 0 and solve it. Now, if it will factor, great. But if it won't, it's quadratic. And I could always solve the quadratic equation by using the quadratic formula. So let's try that. Will it factor? No. Okay, well that stinks, but we're going to have to pull out the quadratic formula and we're going to have to use it. So, we know that x equals opposite b plus or minus square root b squared minus 4 2AC all over 2A, so all over 6. So this comes down to equal -1 plus or minus the square root of negative 59 over 6. And that equals -1 plus or minus I square root of 59 all over 6. So there are your three answers, +2 and -1 plus I square root of 59 over 6 and -1 minus I squared of 59 over 6. So we were going to list them. It says completely solved, so you want to list all solutions. So do not forget that the original 2 is a solution. And then we have -1 plus I squared of 59 over 6. And we have -1 minus I squared of 59 over 6. So there are our answers. Does anybody remember another way sometimes WebAssign wants you to type those in? Do you guys remember this?
Put it all over.
-1/6 plus the square root of 59 over 6 times I. So you'll have to be careful with that. Sometimes they do that. It's just trying to remind you that there are multiple representations of that answer. But if you read carefully, it will normally tell you how to enter your answers. Okay, let's recap on this problem here. To solve a polynomial equation that is not factorable, you first have to figure out one rational solution. And for now, I'll give it to you. I told you it was 2. Then you perform synthetic division on that, and that brings you down to a new factored equation. So now it'll factor. And then you can set each one of those factors equal to 0 and you can solve it. Once it drops to quadratic, you don't need synthetic division anymore. You just will use factoring or the quadratic formula or the square root property. Next time in section 5.3, we will actually be learning how to do if it's not just a cubic, if it's like a 4th and 5th degree. So you'll actually be performing synthetic division multiple times on one problem before you drop into a quadratic. You're excited, aren't you?
No.
I can tell by looking at you. The last concept we need to talk about from this section is the multiplicity of zeros. Now this states that if r is a zero of the polynomial, that means that when I plug it in, it equals 0. It's called a solution, a root, or a 0, also known as an x-intercept if it's not an imaginary number. If it occurs n times, then we say that it is a 0 of multiplicity n. For example, in this problem, p of x equals x cubed minus x squared minus 21x plus 45. We know that, well, we don't know, but your book knows that factors into x minus 3, and x plus 5. And it has the zeros 3, 3, -5. So even though it only has 2 distinct answers, we say that the 3 occurs twice and therefore has a multiplicity of 2. So if something occurs 4 times, it would be said to have a multiplicity of 4.
Isn't this where you do like 3m2?
Yeah, sometimes you would see that written, like in Algebra 2, I think that the people had you write, your teachers had you write 3m2 and then -5. So that and you wouldn't have to list it. Technically that has a multiplicity of 1, but we don't do that. So technically we would just stop right here and we would list those solutions.
So basically whatever makes it go to 0
Is a right, that's where the word 0 comes from. Also called a solution or a root. Okay, so whatever makes it go to 0 is a solution, a root, or a 0. And if they occur more than once, it's said to have a multiplicity of however many times it occurs.
So we're going to write it like that?
Your answers would be written that way, yes. So now I want you guys to understand how problems are made up. At this point, you can make up any problem you want that has any answer you want. So I want you guys to pick 2 numbers for me. 8 and
12.
12?
Yeah.
Okay, those are pretty big. Sure you wanna use them?
One,
Three
one,
and
two.
five.
One,
One,
two.
two.
We've already done 3 and 5.
1 and 2.
How about 1 and negative 2? Is that okay?
Sure.
1 and negative 2? Okay, so we're gonna use 1 and negative 2, and we're gonna come up with a number with a polynomial that has those solutions, positive 1, negative 2. And I want one of them to have a multiplicity of 2. Which one? Positive 1? Okay. So that's what we want to do for our last example. So for our final example, we would like to create a polynomial P of x that has the solutions positive 1 with a multiplicity of 2 and negative 2 with a multiplicity of just 1. So we want to figure out how to make up a polynomial that has any solution we want. It's really easy. First off, you just name the polynomial. We'll call it P of x and let it equal. And you have to write its factors. If 1 is a solution twice, what factor has to be there twice? Is it x plus 1 or x minus 1? X minus 1. So we're going to do x minus 1 times x minus 1 times x minus negative 2, which would be x plus 2. And then you just have to multiply that out. That's all. So we're going to multiply the x minus 1's together first. So these first two multiply to give us x squared minus 2x plus 1. And then we're going to multiply that by x plus 2. Now, I don't know how you learn to multiply a trinomial by a... So, as I was saying, I don't know how you were taught to multiply a trinomial by a binomial. Some of you were just taught to distribute every term to every term. Some of you used the little Punnett square method. But I was wondering if you've ever seen this. So first, I need to multiply x plus 2 by the x squared. Then I need to multiply negative 2x by the x plus 2. And then I need to multiply positive 1 by the x plus 2. So if you think of it as a distribution that way, where instead of just distributing a single number, you're distributing a binomial, it's kind of neat, and it works out very nicely. So we can see that P of x equals x squared times x plus 2 times x squared minus 2x times x is minus 2x squared, and minus 2x times positive 2 is minus 4x, and then distribute the positive 1 and we get positive x plus 2. What I like about that method is your like terms will always be situated together. So I showed this to another class yesterday and I wasn't sure if you guys had ever seen it. So I wanted you to at least have the option to see it. So that means that our polynomial is equal to 1x cubed, and then what happens to the x squareds? They cancel to 0. And then our plain x's become negative 3x, and our constant is positive 2. So that polynomial right there has the two solutions, positive 1 and negative 2. But the positive 1 has a multiplicity of 2. And that's how you create a polynomial that has any solution you want.